We can use a drawing tool to plot the Chem profile. If you have not any drawing tool, you can draw it freehand. I used to use SolidWorks for drawing, so I will show you how to adapt SolidWorks to plot the Chem profile step by step. I will describe the first example, Example 10.3, to plot the Chem profile for a radial flower. First, we need to prepare the leaf amounts of the flower and list them in a table. For example 10.3, flower displacement in inch is given in table 10.6. I select the SolidWorks software and run it. And open the new part document. Let's start by creating a sketch on one plane. I select the front plane to make a sketch. First, I draw a base circle with a diameter of 3 inches and a prima circle with a diameter of 4 inches. I give a small dimensions. (3" and 4 inches. Change the both circle to construction line. In this case, the can rotates in the clockwise direction. If I want to draw the Chem profile, I stay with the Chem in the same coordinate system. It means the Chem is stationary and the follower has an inverted motion relating to the Chem, so the follower rotates in the counterclockwise direction. We need to determine the center position during the follower motion. So I draw a horizontal line for the follower initial position at the Chem angle 0 degree. Rotate and copy this entity every 10 degrees in the counterclockwise direction. I use a circle sketch pattern function to do that. Select the entity and I use the equal spacing for 316 degrees and there are 36 entities and OK. So we get the 36 position like this. We need to get the roller center positions for each roller position. plot the line segment on each ray line outward from the plane circle. Its length is the same as the furrow's displacement. In this case, we only need to draw line segments for the rise and return regions here. Let's see the furrow displacement program. The furrow is in the Radial from the Chem angle 0 degree to 120 degrees. So, its center is on the prime circle. So I draw a circle here. Its radius is 0.5 inches. These circles will be tangent to base circle. And I contour here. This is 120 degree ray line. And draw a circle again. And change the line type into construction line. During the rise to return regions, the roller leaves an amount from the prime circle. For example, at the Chem angle 113 degree, we have the displacement equal to 0.0536 inches. So, I draw a line segment with 0.0536 inch in length. From the prime circle to here, and give it a length 0.0536 inch, and enter. This end point is the center position of the furrow at the Chem angle 113 degree. Let me see the Chem angle 114 degree. We have the displacement equal to 0.2 inch. So I draw a line segment from here to here and give it length 0.2 inch. So I get this end point. This is the center of furrow position at Chem angle 114 degrees. We continue to do that. 115 degree, 116 degree, until to 315 degree. All the line segments are plotted like this. Their lengths are the same as the leaf amounts given in Table 10.3. I select the endpoint here to draw a circle. With the diameter 1 inch. And draw here a circle. its diameter also is 1 inch. So from here to here, we totally have 6 circles here. This is rollers position are the locus of the furrow in motion. All the line segments are plotted like this. Their lengths are the same as the leaf amounts given in Table 10.3. These endpoints are the roller center position, so we can draw a roller circle at every cam angle. I use a copy entity to copy the circle driven its center and go to the end point here, 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 here. From the cam angle 0 degree to 316 degree, we totally have 36 circles here. The rollers position are the locus of the furrow in motion. Then I draw a curve tangent to the roller's position to get the work curve. It is also the Chem Profile. I use a splice and select the tangent position. Okay, so you can see the blue line is a Chem Profile. Finally, we need to indicate the pressure angle. I will show you how to get the pressure angle when the cam angle is 115 degrees. I draw a line along the direction of the furrow motion. This is a furrow motion along this line. And draw a normal line from the Chem contact point. The contact point is here. And I draw a line. This line is the normal line for the Chem Profile. So the angle between the two lines is the pressure angle. I measure it. The angle is 24.1 degrees. So now we finish plotting the Chem Profile.